So hi guys, good morning. So today we're going to talk about the sorting algorithm. So what do we mean by sorting algorithm? So sorting algorithm is a method for reorganizing a large number of items into a specific order, such as alphabetical, highest to lowest, or shortest to longest distance. So here is a visualization of how sorting algorithm works. So for example, if the user inputted an unsorted algorithm, then sorting algorithm works by sorting it from smallest to largest, highest to lowest. So comparison-based sorting algorithm. A comparison sort is a type of sorting algorithm that only reads the list elements through single abstract comparison operation. So just like what you can see in the screen, here is the example of a comparison-based sorting algorithm. So there are many types of sorting algorithm. One of it is the bubble sort. So bubble sort, sometimes referred to as sinking sort, is a simple sorting algorithm that repeatedly steps through the input list element by element, comparing the current element with the one after it, swapping their values if needed. So here is an example of how bubble sort works. So first pass, we have the unsorted algorithm 7, 6, 4, 3. So by swapping it, so 7 compared to the next element, which is 6, is greater than. So then we can swap it. So on the second pass, so since 7 is greater than the next element, then they will swap. So 7 is greater than 4, then swap. So as long as the next element is smaller than the current element, then we can swap it. So as for the second pass, we have the 6. Since 6 was moved by the 7, so it is on the first element. So since 6 is greater than 4, then we can swap it. Then 6 and 3, so which is greater, diba? 6. So swap. Then we have the next element, which is the 7. So since 6 is smaller than 7, we cannot swap it because it is sorted already. So on and so forth. So that's how bubble sort works. So it is referred as a stinking sort. Later on, I will show you how the code works. So next we have the selection sort. So selection sort is an in-place comparison sorting algorithm. It has an big O n squared time complexity, which makes it inefficient on large lists and generally performs worse than the similar insertion. So next we have the selection sort. So by its definition, it is an in-place comparison sorting algorithm. It has a big O n squared time complexity, which makes it inefficient on large lists, and generally it performs worse than the similar insertion sort. So here is the visualization of how selection sort was made. So for we have the element 20, 12, 10, 15, and 2. So by this, it selects from the greatest to lowest. Then compare it to the large list. We also have the insertion sort. So insertion sort is a sorting algorithm in which the elements are transferred one at a time to the right position. In other words, an insertion sort helps in building the final sorted list one item at a time with the movement of higher rank elements. So here is an example of the execution of the insertion sort. We have the unsorted element of 4, 3, 2, 10, 12, 1, 5, and 6. So we'll select it from the first element. We have the 4 and the next element is 3. Since 4 is greater than 3, then we select it to the next element. Then sort until masort silang tanan. Next, we have the merge sort. So merge sort is one of the most efficient sorting algorithms. It is based on the divide and conquer strategy. Merger sort continuously cuts down a list into multiple sublists until each has one item. Then merge those sublists into a sorted list. So basically, merge sort is dividing it into two. So we have the six element, we have 6, 5, 12, 10, 9, and 1. So how are we going to do it? So we need to divide it into the median. So the median is 12 and 10. So we're going to cut it into 2. So on the left side, we have the 6, 5, 12, and on the right side, we have the 10, 9, and 1. So we can sort it by doing it one by one until each has only one item, then merge those sublists into a sorted list. Later on, I will show you how the merge sort really works. Next, we have the quick sort. So quick sort is a popular sorting algorithm that is often faster in practice compared to other sorting algorithms. So it utilizes a divide and conquer strategy to quickly sort data items by dividing a large array into two smaller arrays. So it was developed by Charles Anthony Richard Hoare Merge. So quick sort is similarly like a merge sort where we divide and conquer it so that the large array can be put into two smaller arrays. Last we have the heap sort. So heap sort is a popular sort and an efficient sorting algorithm. The concept of heap sort is to eliminate the elements one by one from the heap part of the list and then insert them into the sorted part of the list. So heap sort is the in-place sorting algorithm. So here you can see the visualization of the heap sort. So let's go to our ID. So as you can see, we have a bunch of sorting algorithm code. So first, we have the bubble sort. So we have the public class bubble sort example. Then let's declare our number of elements and how many elements we can input into our code. So enter the elements, then sorted array. So here is the function on how bubble sort works. So if we run this, we will have it. So first, we need to enter the number of elements. Example, if we inputted 5 unsorted elements, so we got the 4, 2, 6, 9, and 1. So bubble sort will sort it into a sorted one from least to greatest or smallest to largest. So here is the sorted array of the unsorted elements. We have the 1, 2, 4, 6, 9. So next we have the heap sort. So here is the code for the heap sort. You can post the video for the source code. So here we have our main class. We have the public class heap sort. Then enter the number of elements. Then here is the function for the heap sort. So we have the int n, which is the declaration of the number of the elements that was inputted by the user, is equals to array.length. So for int I is equals to n, divide 2, I greater than or equal to 0, then I minus minus. So heapify then. Also, we have the methods for the heap sort. So here is the code. Then public static void print array. This is used for the displaying the sorted array. So if we run this, here is the code. First, we need to input how many number of elements are we gonna use. So example, we have inputted 4 elements. So first, this is unsorted guys. We have the 8, 1, 555, and 3. So through the function of the heap sort, then it will be sorted. So we have the 1, 3, 8, and 555. So basically, that's how sorting algorithm works. Um, Based from our PowerPoint, you have already learned what is the definition of the insertion sort. So it works one by one until it can be sorted into least to greatest and smallest to largest. If we run this, we'll have, so we inputted 5 unsorted elements. We have there 3, 5, 2, and 6. So here is the sorted array of the insertion sort. Next, we have the selection sort. So from the definition, selection sort means selecting an array. So it has a 0 and squared time complexity. Here is the code for the selections sort. You can post the video for the source code. Last, we have the merge sort. From the definition, merge sort is divide and conquer, which means divide it into two until one of them is only one element will remain, then merge the sublist into sorted array. So we have our main class, then we have this function in order for it to sort the unsorted elements. So if we run this, we'll have an output like this. So what if we inputted 10 elements? Then we'll have the unsorted. 1, 5, 23. So here is the sorted array for the merge sort. It was divided into two, then conquer until one of it will remain, then merge the sublist. So I hope you learn from this video. Thank you so much for watching.